Logistic regression. Let's learn about the logistic regression. Certain time, we have a data into the form of categorical data. The categorical data are into the form of yes and no, or they are into the form of true and false. So whenever we are having the data into the form of yes and no and true or false, there we do apply the logistic regression. If we say here, generally when we do the linear regression, at that time my data are representing into the continuous value data and my best fit lines move into these directions. But certain time situation arises when my data are representing either into the yes or no circumstances. Mean either I'm having a yes or I'm having a no. So in that case, if we apply the linear regression model, so that will start making the best fit line in this way, where the model is not learning the data well. So in such cases where I'm having a data with the yes and no answers only, so this linear model will not able to apply in such a situation. We need certain alternative. So what we can do it here? Simply we can apply in this situation. If the situation is here, if we are getting this data here. So suppose this is a kind of a data related with the diabetic data. So there are certain patients' data are provided where one has to assume whether the person is having the diabetes, yes or no, whether the diabetes are present there into the patient body or no. So only two conclusions are there. So in that case here, some of the data are with no, the data which are lying here are with no, and the data are which lying here, they are into the yes condition, yes diabetic, no diabetic. So when such condition arises, so there we need another function that is known as the logistic function. Here we apply the logistic regression where we are coming up with a decision of only two values, either the yes or the no. So this is a logistic regression basically. Logistic regression is represented by the equation here. That is represented by the equation here. Log of P1 minus P. So this one is the probability of having yes data, and this one is having the probability of no data. So this is the basic equation which is used underlying into the mathematical model for logistic regression. So this logistic regression here, the probability of predicting yes and divided by probability of predicting no data here. So that is also represented by E y over 1 plus EY, and this y is basically the linear regression. This y is representing the linear regression. So this one is equivalent to this linear regression. So this one is a logistic regression equation. This one is working behind the logistic regression algorithm, which is used whenever we are having a data into the form of only true and false condition. So remember, whenever we are doing the linear regression, it means we are dealing, inside the linear regression, we are dealing with the continuous values, every time continuous values. All our data are with the continuous values into this format. And whenever we are dealing with the logistic regression, only two values are there. The logit are there. Logit itself means logistic. Logit itself means logistic. Logistic means two, means binary values, true or false, or I can say yes or no. So there we can just use directly logistic regression. Now we can see here for the same one, if we are having a kind of this data, so here our linear regression will be a problematic. My model will not learn the data. So in that case, I have to go with another solution. In that case, I have to go ahead with logistic regression, where the model will learn this data and this data. So model will learn how many cases are with the yes and how many cases are with the no. So in this way, the model is going to learn. Now, when the model is going to learn here, then we are going to split the data once we are using this model in such a case here. So here we are going to make the split of the data as the training set and the testing set here. So 80% of the data is divided into the training set, 20% of the data are divided into the testing set. That we can do that. So let's take a case of PIMA Indian diabetes data set here, where we are having few X variables, which are the input variable, and also we are having the class variable, which is going to be done as a Y variable. So here many of the input variables are given, such as number of times pregnant, plasma glucose concentration, blood pressure, skin fold thickness, certain tests, insulin tests are there, body mass index, pedigree, diabetes pedigree function, and the age of the person. And the last one is the class, where one has to predict whether the person is diabetic or no diabetic. So only we are having the value with 1 or 0 only. So how to apply it here? So here we have to apply the similar way. We have to take importing of the data set. We can take any CSV file or any text file here. We have to import the libraries. We can split the data into the train and the test. And then here we have to apply the logistic regression, and we can validate the model by making the test use here, by using the test data set here. Now let's see a few lines here, how to draw the data set here. Here we are drawing the data set with the read.csv, as the file is available into the CSV format, PIMA Indian diabetes.csv. I'm calling it here. Now for the train test split, I had applied for the library CA tool, which will allow me to make the train test split of 80 and 20%. So here we are calling it here sample.split. We are splitting the data, this data where the CSV data are present. Split ratio, one can give it here 0.7 or 0.8. So 0.8 itself means 80%, and 0.7 itself means the 70% data we have to take it here. And here then once we are having the split of the data, then we can use the subset of the split data. Data split is equal to true means we have to take one type for the training and second type for the testing. So we are having training and testing data set ready. Now how to call the logistic regression? So there is a model, generalized linear model. This we have to take, and inside it we have to specify the Y variable, mean class, which we need to predict as the 0 or 1 or yes or no. And here, because inside PIMA Indian diabetes there are many input variables, so I want to call all. So simply here I can give just only dot, which will be representing many input variables. Once it is done, then there is one of the parameter here inside the GLM, means generalized linear model here. There is a family parameter which needs to be settled with a value of binomial. So if we settle this value with a binomial, so binomial means do the logistic regression. Binomial itself means two outputs, either yes or no. So here we'll be calling this binomial, which will be settling down the logistic regression functionality. The data will be trained with training data here, then we can check out the summary. Once it is done, then we can make the data, the model validate here. So here we can use the predict function. Inside that we can pass out the same trained model. And here we can keep the training data just for the initial purpose. Type is equal to response. This one is the parameter we need to settle. So it will be giving us the response. Now we can create a table here, cross table here, where we can show the actual value and the predicted value. And we can see what are the predicted value whose response are greater than 0.5. Now what is this 0.5? Let's understand it. 0.5 itself means that whenever we are doing here the logistic regression, whenever we apply here logistic regression here, so some of the values are here on the 1 position, some of the values are here into the 0 position. Now this is a 0, this is a 1, in between there is a 0.5 also. This is a threshold values. This is the threshold value. This is a threshold value. So suppose here whenever logistic regression equation works, this equation works. So this is a logistic regression equation. So here the y data are going to be worked. Suppose here b1 x1, b2 x2, b3 x3. These data, and the similar one is here. These are the here. So here and move on. So till we are having the input variable. So it will be calculating y on the basis of intercept and the coefficient values coming for the different input variable of x. It is going to calculate y. Once the y is calculated, then it is going to find out the exponential of y divided by 1 plus a exponential of y. When this equation is resolved internally, so then in that case, one has to think it here that what is the answer coming here? If we are getting the answer, because all the answer should be above or below 0.5 threshold. So when this entire equation is resolved internally, so it will, we have to check what probability it is giving internally. So suppose here we are getting the entire response for this one, suppose here 0.48. So 0.48, so it means 0.48 is here. So it means we are getting predicting probability less than 0.5. If we are getting predicting probability less than 0.5, that is a 0.48. So we will be assuming that data as a 0. Okay. And if that one is above 0.5, suppose here in case I am receiving this entire, once this equation is entirely resolved, I am getting any value 0.83. So 0.83 is lying above 0.5 here. So this, it means that particular patient is having one value. It means yes, diabetes. So if we are getting these probabilities below 0.5, so it means that patient does not have the diabetes. And if we are getting these probabilities above 0.5, so those patients are having yes, diabetes. So here no will lie below 0.5 and above will lie yes, above will lie here any probability which is lying above here. Yes, so that they are with yes diabetes and here with the no diabetes case. So 0.5 is to be considered as that threshold value. Above all the value of 0.5 will be considered with yes diabetes. Below 0.5 will be considered as the no diabetes here. The same one is given here that show me all the values which are above 0.5 here. So response, show me the predicted value greater than 0.5. So that is going to deliver you the values which are above 0.5. It means yes values it is going to deliver. And when we will be checking out these equations, means when we'll be running that entire these codes here into the R. So we will be receiving, when we are checking out the summary models, we will be checking out the intercept and the coefficient values. So these coefficient values will be taken while calculating the equation of this one internally for logistic regression. So into the Y, these coefficients will be taken as a plus b1x1, b2x2, b3x3. So into the b1 and b2, these coefficients will be fulfilled along with their input variables values. So they are going to be worked there in the backend of the logistic regression. And this is the same equation which I am discussing that is going to work in the behind of logistic regression. So all the coefficient values will be moving here into this equation, and then this is going to give you all the values which are above 0.5 or below 0.5. So any value in the response of this Y above 0.5, they will be considered with yes or 1, and below 0.5, they will be considered as no or 0. So in this way it is going to work with logistic regression. Now let's see certain examples of logistic regression.